So, good evening, everybody. So, today we are having the second talk by Mr. James. So, last time he gave a talk on how to manage an Excel sheet, and today will be a continuation of the same class in addition to a few uh, description about RedCap. So, to give a small introduction, Mr. James is a certified ophthalmic technician who completed his course between 2014 and 2016, following which he was the clinical research coordinator at the University of Michigan. And currently, he is pursuing his PhD in the community health services and is the lead research administrator at the University of Michigan. Over to you, sir, for your talk on how to manage an Excel sheet and the RedCap database.
Great, thank you very much. Just double checking that you can hear me okay.
Yeah, very well.
Okay, perfect. So I wanted this conversation to be a little less formal than the last one. I was given a number of Excel spreadsheets to sort of glance over and provide some analysis, critique, and maybe give some tips on each. It's my understanding that you have them available and can kind of follow along. Is that correct?
Yes.
Okay, perfect. So I'm going to open up and perhaps share my screen here with the pre-term Excel spreadsheet. There we go. Is that up? So, so for a little bit of disclosure, I'm not an active researcher, but I do have some experience in building databases, and I have I spend a lot of time looking at regulatory compliance of data sharing agreements. So when I'm looking at these sheets here, I'm looking at them through the lens of collaboration and what the University of Michigan would require if we were to share some of this data, and then also to look at how to make some of these just a touch cleaner. I think overall, the spreadsheets that I was given, serve their purpose. They do what they're supposed to do. So looking at the first one, the preterm, the first thing that stood out were these sections with medical record numbers, infant's name, and then name of parents and contact numbers. So generally, when we're looking at what to put in a spreadsheet, we want to keep the bare minimum for what is necessary to conduct the research in the data sheet itself. Generally, under ethics review, you can keep these identifiers. You may need to look into their charts for additional information after you start analysis. But in general, those things should be kept in a separate sheet that's not directly linked to their study ID numbers. We want to just make sure that nobody could link any identifiable information to research data. So that was the first thing in this. The other things here, we talked last time about creating a data dictionary, and some version of that is present in all of the ones that we'll talk about here, but they're hidden in comments. And I think that's okay, especially here, right, where you have the code of what that means. It may be a little cleaner to have it on its own separate sheet. but the information is mostly here. Overall, I don't have a ton more comments on this specific one. Do you guys have any questions? I'm really looking for a little guidance too from you on what any specific questions that you have over these that I can attempt to address. Oh, and one other thing that I just mentioned here, we want to try to keep words out of these data sheets. So in this case where it's both 1 and 2, if you see that, I would probably create a new definition and give it, a 0 or a 3 or a -1 if it's not necessary for the data, something like that. Any standout questions on this?
Thank you, Mr. James. We can proceed to the next one.
Okay, so I'll move on.
Yeah.
And
you're able to hear me?
Yes, I can hear you now.
Yeah, okay. Yeah, there are no questions in this. Thank you very much. We can proceed to the next one.
Okay, great. So on the next one is the sibling sheet. Generally speaking, the same comments of the first one are here. The data, I would take away anything that is identifiable and keep that in a separate place. All of your data dictionary elements are present in comments. That's fine. I see that this is, there's a lot of highlighting going on. And so I'm assuming that this was done to pick out statistically significant or interesting pieces of data. And by the looks of it, they were all hand highlighted, by going through each individual cell and picking a highlight if necessary. So one thing that I can recommend doing that would make that a little bit easier, let's take this column T just for a quick example. So if I'm glancing at this right, it looks like all of the numbers highlighted are under, maybe 339. That's probably what that means. What you can do to sort of auto pick that, we can just, select the entire column. Move my screen here out of the way. And then in the section here, there's this conditional formatting button. If you click that and go to highlight cells rules, you can give that column rules on when to highlight. So let's say this one, any number less than 339.5. Oh, it looks like this may have been done. It's hard to tell sometimes. Okay. So same thing. You can give it different or even custom format. So if we want to highlight cells yellow that are less than 1.54, it would just go ahead and highlight all of that data for you. Okay. And then this is also an opportunity, perhaps, to use the pivot table elements. You can select the entire sheet, create a pivot table that is the entire set, and then you can create your own columns and rows to compare. And give these different things like average. That's obviously a bad example. But you can play with these settings, filter by gender, average,
Mr.
best
James, can
corrected.
you zoom it a bit?
Yes.
Yeah, we're not unable to
zoom in.
Yeah, yeah, okay.
Does that help?
Yeah.
I mean, I don't think what's happening in here is super important. I wish I could zoom in more on what I'm doing down here, because you can see that you have all of your data elements here in the pivot table fields. And you have a lot of flexibility on kind of what you want where. So for example, if we wanted to split it up by age, I would probably put it as a filter. And if we're looking at uncorrected visual acuity in the right eye, we want both the values. So we can see that out of all of the participants, 2 participants had visual acuity of 460, whereas 52 participants had a visual acuity of 6.6. In this case, it may be nice to know what the average visual acuity was, but that cannot be done easily with sort of the traditional visual acuity measuring. That's when converting into something like a logmar, where you get a number with a decimal point. It may be easier because you can get an average, but maybe that's not what you're looking for. Maybe just knowing that 52 of the 84 participants had 6.6 vision is enough. I'm unfamiliar with what the P means.
It's parts, like we read half the line correctly.
Oh, plus. Got it. So slightly better than 6.6 is what we're saying. In cases like that, you might want to have a consideration of whether that is statistically significant enough for you to want to include as a separate item. Because
yeah, we can remove that.
So, because only 4 of them had it, so you could add them to here and then put a note that this 6.6 means 6.6 or better. Again, those are small things that you'll sort of need to decide. But
how do you go to this pivot table?
Yeah, so what I did here was I just sort of selected the entire data set. You can do that by clicking this corner, and it highlights everything. And I have a button here at the very top called Pivot Table. If you do not have that, I can show you how to get it. But there's a couple ways to do it. So you can either go to Insert and click Pivot Table. it'll ask you what your range will be and whether you want it to be placed in a new worksheet or in the existing worksheet. I almost always do a new worksheet just so it does not interfere with anything that I have going on. And then it'll give you this blank page. And that's when you have all of your data elements on the right side here. And you can sort of play with how you want that to show. You can so let's, oh my goodness, sorry, it's dragging. So I'm not sure, you know, for this data set, what would be the best way to do things. But let's just stick with gender and uncorrected visual acuity. So right now you have, it's not super useful, but what you have is a top column of all of your visual acuities, and then the bottom comparison here is the gender. And so what we want is, no, we want values. So in a very quick way, this shows us that 49 of the participants were 1, which, going back to your data dictionary, is male. 35 were female. 27 males were 6'6", 25 females were 25. It gives you sort of an overall count of how many of, you know, total. And then just at a quick glance, it gives you an idea of overall data points. Now you can also sort of move these over if you need to. So they're in order for you. You know, these are a bit out of order. And it doesn't mess with the actual numbers. You're still getting the counts of each person. So that's a real easy way, I think, to sort of see at a glance what you're working with. Now going back to here, and I'm sort of just playing with this at this point. So this Art Max right eye. So we could potentially go back into our columns, find the Art Max and put it in filters, right? You see what I did there? I took the Art Max right eye, made sure it's in the filters column. And let's, by clicking this arrow here, we have a new box, Art Max right eye. This right now it's showing us the data for all of them. If we were to click this button and go down to select multiple items, you can see that you have all of the ranges, all of the, everything that was there, right? So we can deselect that and maybe just click the ones that are under 300, let's say, or under 200, just to make this a little bit shorter for the sake of presentation. We say okay, and what happens is all of the participants that meet that criteria of having the Art Max right eye less than 200, 4 of them were male, 1 of them was female, and then you get their visual acuities, which is, again, just a nice way to pick out certain elements of your data at a glance. This doesn't do a whole lot of the brain power for you, right? This isn't a statistical analysis, so to speak, but it does help you sort of pick out trends, and it can be interesting depending on how you want to look at things. Is there any questions here? Anything I can repeat or show again?
Oh, okay, Mr. James. No questions here. We can proceed to the next one.
Okay, so the next one that I have on my screen here is the anisometropia. New share. Okay, did that switch for you? It's hard for me to tell. So this has the same same comments as before, right? We have a data dictionary in place in comment, which can make it a little confusing to see at a glance, but is there at least. I'm not sure how this break happened. This is something I have not seen. So whoever made this one is doing some advanced techniques, which is sort of nice because you can separate these. This is a very long data set. So I can see why that would be easy. So you can get you can pick one side to look at here and scroll over. I would say that the pivot table would probably do the same thing if you wanted to pick out two data elements sort of quicker. I don't have a whole ton of comments on this one. Yeah, so main complaints have specific numbers where anything that needs additional comments are separated. I think that's a good use. Here, there's one abnormal. I would maybe put a new box for comments for abnormal rather than keeping it in the column. Just because when you're doing a data analysis, software is going to be looking for ones and twos, and then you have a 2 plus words. Having those separated might be better for the people who run these through the software. But overall, that's the only one. So I'm not sure how significant that might be. And then for NA, I would maybe give that a -1 or something that just shows that it can be excluded easier rather than having words. But again, that's a small preference thing. I don't have a lot to say about this one other than the things that we said already. And so I'm going to move on.
What do you suggest instead of
go ahead.
What should we be writing?
Could you repeat that one more time? I'm sorry.
Instead of NA, what do you suggest that we have to write?
Well, so it can be anything that's consistent. So NA is fine. You know, everybody knows what NA means. When you're dealing with software that is mostly looking for numbers, having a number that means NA could be helpful. So in a lot of cases, I've seen, so instead of NA, they put in a new, a negative number, like -1.
Okay.
And so that way, when you're going through, you can just exclude any negative numbers and move on. But again, you know, I think you're having some talks with statisticians in the coming weeks, and they may be able to better discuss what works for them. But in the things that I've seen, in the way that I've seen things built, usually these are just assigned a negative number or a 0 to indicate that there's nothing there. Or, you know, so in this case, so the systemic illness history, so the 2 means no, and then there's an NA. So you could also just leave these blank, right? Because these look like comment boxes, and these wouldn't be, we already know that they're not relevant if this number is 2. That's another option for
Leave
these
those
types of things where
empty.
you're, what's that?
Should we leave those empty, or should we have to fill something?
So in this specific example, just talking about systemic illness. So the systemic illness history has, so it's asking, is there a history of illness? Yes or no? In the cases where it is no, we don't need to clarify that. So I would, if I was building this, leave these blank because there's nothing to add. These are comment fields to justify the answer in H. And then here, where there is a history, the comments are written out. So I think in this specific case, leaving these blank may be the best option because they're comment boxes to help support a selection. And if the selection is no, then we already know that this is NA. That's sort of just adding a redundant text where we may not need it. Here, when we're talking about kind of allergy, so again, allergy is yes or no. This is no, so we already know that this is NA. This could be just blank. And then you have different rules that apply for if it's yes. And so, you know, just making that, let's just take a look quickly. The seizures in 7 years and the kinds of allergies stand out a bit more without the NAs there. So that's one thing that can help catch your eye. And then 2, there's just less data for a statistician or a researcher to have to write down or sift through. If there's nothing there, there doesn't necessarily need to be anything written. Now, in the case where you're looking for, let's see if there's another one. So cylindrical power. So this is a -3 sphere. So again, so this is generally going to be looking for numbers, right? We're looking at average. If one of the points you're looking for is average cylindrical power, you know, your NAs should be 0s, I would think, right? because there is no power there. It's, you know, it's more of me just being nitpicky about not liking a lot of words in these sheets that are, you know, meant to be. If you can quantify all of your data points, it makes data analysis a little more streamlined. That's just my greater point. I think so. If it doesn't need to be, if the answer is nothing and you're looking to just add a word or number there, either put a proxy number that means the same thing as not applicable, or leave it blank. I think would be sort of what I would be doing. And here's another one. Oh, we already talked about that one. So, you know, putting the comments in a separate file, so, you know, you can separate by ones and twos more easily. I would leave the question for how to best write out, you know, glasses, prescriptions, powers, corrective numbers for spherical powers. Because I'm not sure if zeros would alter the data in a sort of a biased, slanty way. But having NA it's probably better to leave it blank. But that's up for what you're looking for and what the greater purpose of the study is, I suppose.
And another doubt, how did you freeze the left side of the field, or is it duplicated?
It looks duplicated. I didn't do this. This came to me like this. And so I'm not, you know, 100% sure how exactly that was done. I'm going to have to do some some digging in Excel to figure out how to turn that off or turn it back on. That did come to me like this. There is a way, you know, if you wanted to freeze at a specific point to, oh no, here it is, split. There we go. Nice. Okay, so there's this in view and split. You can choose where to split the screen. That's kind of interesting. So the purpose of that would be to stop, you know, if you want to keep all of this data here, you choose split, and then you can keep moving this data this way and still review this side, but then still be able to move this if you needed to. Interesting. I've never used it. Freeze panes does sort of the same thing. If you're stopping at education, you can just hit freeze panes there, and it'll allow you to, these ones will stop moving and there's no scroll bar, and you can still move everything here while still being able to see sort of where you placed that freeze, and then just unfreeze when you're done. Okay. Was there anything else on this one? Okay, I'll move on to the glaucoma sample. And I will say that the data here in the glaucoma sample is really great. There's a ton of information that's listed here. So the comments that I would have on this is, one, make use of a data dictionary so we can reduce or simplify the number of words present. Because reading through every single thing can be a little bit more difficult.
Can we zoom in a bit? It's
oh,
not...
of course. All right, so so there's a lot of written words here. So the questions that I would ask in this sort of case is, how much of this information is necessary for the research you're doing? Because what we want is sort of, the minimum. We want the minimum amount of data to be able to support the research. So, and I'm not making any comments about the type of research. You may need all of this, and that's fine. I would say that maybe so education grade, I would give it, ranks. 1 means primary, 2 means graduate. I'm not sure exactly the primary and comes before high school, I imagine, yes. Primary, high school, graduate, postgraduate, secondary. Give these numbers and then put the numbers in here. And that accomplishes 2 things. One, it makes your data collection smaller, and there's less opportunities for creating a typo or a spelling mistake that could leave out data elements when you're condensing this. Occupations may be important to the research. That's fine, and that would probably have to stay as a word. That's a comment that I'll be changing. Urban or rural, right? 1 or 2. Distance traveled could be condensed into, so instead of saying 3.5 or, like half an hour, if we're just measuring distance travel in hours, and we already know because our data dictionary tells us that we're condensing distance traveled into hours, this can be 0.5 instead of half an hour. It's going to be, 2 hours. It's going to be 11.5, and so on, right? So we can condense the data points here as long as this is distance travel is previously defined to be in hours. We don't necessarily need the words there. And then when you are taking this row and trying to create an average of how many hours, because right now, if you're trying to get an average of this, it's not going to be able to calculate it. It won't do it because, well, one, the hours and the minutes are separate, so it's not giving an accurate read. And 2, Excel has some issues with words. So if you condense it all down to just numbers, then you can get a quick look at an average here. I don't know if you can see where my mouse is circling. But right there at the bottom, there's an average. Or when we move it into those pivot tables that we talked about before, it'll do that work for you. And so that general comment can be expanded throughout this entire thing, you know, in places where there's words where, you know, half of the data is the same. I would give it a 1 or a 2, you know, private, general, other. Self-screened 1, or self-referred 1, screened 2. Reasons, if they tend to be the same. You know, 1s and 2s. Vision, we have the same comments as before. If you need to keep the plus, keep the plus. If not, make a comment that 6.6 includes 6.6 plus, and that way you get a, you know, less letters overall.
Rather, you suggest for the vision will directly enter in logmar scale for better understanding and evaluation.
Yeah. Logmar, it's not for every piece of data. If you're looking at visual acuity specifically, Logmar was more or less created to get an easily quantifiable representation of vision. And there are ways, I'm not an expert at it, but there's ways to convert these to a logmar scale. And then that way you're getting just a number rather than, because when you're looking at, you know, 6/24 vision, Excel is treating this as a 6 divided by 24, right? It's treating this as a mathematical formula. And so if you're trying to get an average vision, it's not going to be able to do that unless you were, unless you manually made a count, which you can do. We showed that in the pivot table example. If you make a count of how many people had 6/9 vision per se, you could say, you know, the mean or the median vision was X. But in logmar, you can get an average vision in the logmar number, which can be helpful in its own way. For, you know, statistical purposes, logmar can be quicker. If that's not the object of your study, if that's not important enough, then this could be fine as is. You know, every study is going to be a little bit different on exactly what they need. So I hesitate to to give a broad instruction. These should be taken more as just things to think about when you're creating a data set. Is, you know, how badly am I going to need to quantify this data, and how can I do that in the easiest way? You know, these are hyperopia, myopia are easy to do 1s and 2s with. And then, well, there's a lot of.
And for the sphere and
There's a lot of.
just we put 0 instead of dash.
Yeah, I would probably want to follow that up with one of the ophthalmologists or statisticians that are coming later. In my non-doctor brain, I would think that putting a 0 or leaving it blank would make more sense. Instead of writing out NA. But if that confuses your formulas, then maybe there's a better way to do it. I'm going to be just full disclosure. I don't know 100% the answer to that question. So I would leave that to a.
Okay, thank you.
Yeah. And then the other thing that I'm just noticing right here is that it looks like there's some variation in plus and minus cylinder visual acuities. I don't know if those are typos or if there's just mixing plus and minus visual acuity.
No, they are not typos.
Methods.
It's the actual.
We'd probably want to keep those consistent so that, all of if this is something that you're taking, or is this, I mean, I don't know specifically, but I would convert manually to plus cylinder if everything else is in plus cylinder format. Just for consistency of data. And then again, we have, I don't know if sorry, I have to move my screen here. So if these highlights are manually put in, but there are ways to highlight everything at once. Just select the row or the columns, conditional format, highlight greater than, let's say 30 to be red. And hit OK. And then that we'll just make every number above 30. Now see, that one is 30 and it's not highlighted, so you may need to be a little bit more specific. Greater than or equal to 30. But you'll see that everything above 30 here pops up. Also, things that are blank or words will pop up. Again, I don't know if that was the goal of these highlights. And you can give those different ranges too. So let's just look at this group of numbers. So we can do, so this is again, home, conditional formatting, highlight cells. Let's say less than 20 is, I like the custom format. Less than 20 is green. And we can put in a new rule. Between, so this is going to be your inclusive, between 20 and 30 becomes yellow, right? Or even, 20, 39 if you wanted 30 in its own way. So, this is a quick way to let certain data points pop out for you. You can also bring that into a pivot table, throw IOP at presentation into a filter, and then manually choose, I only want to look at IOPs that are greater than 30, and you just deselect anything under that number, and it'll only give you the data points that you're looking for those folks. So here, another one, right? We're looking at PACG and POAG at first quick glance look almost identical. If you're just manually looking through these, it may be a little bit difficult to pick them. You know, a 1 or 2 is quicker. And then again, here we have a lot of, like, this is just right from the medical record words. I don't know if that is necessary for research, knowing what their follow-up is, unless it's for you to know when to check the data again. But I would try to put into words as many as you can. You know, if you're using the superior temporal thinning, that could be 1. You know, inferior thinning is 2. Inferior temporal thinning is 3. You can minimize these words. And it may make this easier to parse through. But again, it really depends on what you're doing it for and what you need. Any other questions on this one?
How do you suggest we write the visual fields and OCT in the Excel, like full words or?
I probably wouldn't use words unless the words are necessary. So in these cases, we're looking at OCT, and you're going to get generally 4, well, probably a little bit more than 4, but you're going to get common findings. And so if you can condense those findings into a number, you know, so superior temporal thinning is 1, and then so everyone that is just superior inferior thinning or in superior temporal thinning is 1. Great. In the cases where there's more, you could give that another number. Or a second thing that you could do is, so I'm noticing there's a lot of blanks, which I'm assuming either means that an OCT was not done or the findings were normal. And in those cases, you could instead add a column here. You know, let's just play with this. You know, was OCT done? You know, yes or no. If yes, you know, findings. And so if there's something here, you can put in a comment what the finding was. In which case you can kind of delete out anybody that didn't have an OCT or anybody that had abnormal findings. It can be tricky to get that in the best way.
And suppose there are multiple selections that you have to take. Suppose we have mentioned superior as 1, inferior 2, temporal 3, nasal 4. Suppose both 1 and 2 are there, how do you enter that? 1, 2, or do you give another separate number for that?
Yeah, so in those cases, that's going back on what I said a little bit. In those cases, it may be better to put it into words. I'm trying to think. So again, this is where being a doctor may be a little bit better for for how to enter it in. But I'm just trying to think of how many possibilities there could be. So if you can assign a number, so 1 is super temp, 2 is inferior, superior, inferior, superior and inferior is 3. Maybe you could do it that way. Or you would just say, you would give it an extra column that says, you know, normal, abnormal, and then if abnormal, here are the words to describe what the abnormal findings were. But my point is to try to reduce the amount of words and to clarify what blanks mean. Because looking at this, I don't know whether no findings means it wasn't done or whether it was normal. Don't know why that's doing that. That's where a data dictionary would come in handy, because it would explain what these boxes, what we're looking for in these boxes, and what those things mean. So I think, just to backtrack a little bit, I think in this case for OCT findings, there's probably too many possible outcomes to give it each an individual number. But having an extra column that explains whether or not an OCT was done and whether the findings were normal or abnormal may be helpful. And it could even be that when you're looking for the findings, what you're really looking for is whether it was normal or abnormal. Is it important to the research that we know exactly how it was abnormal or just that it was abnormal? That's going to depend on what you're researching. But if you're only looking for the number of abnormal OCTs in this population, you wouldn't necessarily even need to know what the specific findings were. You could just say abnormal, normal, and move on. So there's not a one size fits all approach to this. It's just things to think about on what do you need to successfully accomplish what your research is doing. If you want to know the exacts, then keep the exacts. But again, just explain too, you know, if there's words, why are the words? What do they mean? For somebody who is not you, if for collaboration for statistician support. Yeah. So I'm looking at the time, and it looks like we're at 8:30. Did you want to run through a quick recap, or maybe move that to another day?
Whichever is comfortable for you, Mr. James. Like, if you can quickly run through, we can run through. Otherwise, we can plan it later.
Yeah, well, you know, I have it open. Let me maybe take the next 5 or 10 minutes to do a brief look. Sure. And then if more questions come up, because when I was looking at REDCap earlier, sorry, I'm trying to log in. You know, a lot of what we were talking about is already there. So let me just go into, okay, so I'm in the landing page of the REDCap training environment. I like using this. If you're not doing real research, I encourage you to play with the training environment. because it lets you make a lot of mistakes without it actually mattering. And you can see I have a few other forms and things that I've made. So I'm just going to start here with a new project. Project title can be anything, but should be your project. This is going to be research generally. And then, so if you're doing it for research, it's going to ask all this information. We're going to do, for the purpose of this, just practice. And we're going to create an empty project. That's a warning that we're only doing this for fun. And so this is the REDCap home. So the one thing that I definitely wanted to point out in REDCap is in this design your data collection instruments section. So this is where where most of your pages are going to be made. And then there are how-tos for almost everything you can think of. So one thing you can do, let's just go right to Online Designer. Create a new instrument from scratch, add instrument, let's say visual acuity. Okay, so this is, so everything that I want to know about visual acuity is going to come in here. So we can, when you add a field, you select the type of field. And this is a backwards way of creating a data dictionary. So this is REDCap doing it for you. So this is giving it the rules of what the data collection instrument is meant to do. So is this a text box with just a short number? Is this multiple choices? Are there multiple answers? Is it just a yes, no question? Is it a true or false question? So that's where you want to start. So in this case, you know, we're going to do let's say multiple choice. And so this is where you would put your options. I'm sorry, I'm not familiar with doing it in metric, so I apologize for taking a quick glance. 6, 6, 6, 9, 6, 12. Okay. 6, 9, 6, 12. So variable name is present. Is actually no. So we want to do enable auto naming. That's I like doing that. Field type, choice, field label. Field label. Okay, let's go back for a second. So field label, this is going to be the name of what you're looking for. So preventing visual acuity. Okay, and the choices are going to be sorry, that was a typo. I'll show you what that said in a second. So when we get out of here, it yells at us saying that the choices below didn't have a raw value, but only had a label. So raw value has been provided. And so you'll see that it's given a number for the option, right? So when this gets pulled out into, when you pull this out into an Excel spreadsheet with all of your data points entered, all of your 6 6s are going to be converted into ones. All of your 6 9s are going to be converted into twos. All of your 6 12s are be converted into threes, and so on. Other things to note is whether this is a required data point for whoever's entering the data. If you say yes, they cannot submit. You cannot enter the data into RedCap without this being checked off. If you say no, it will allow you to submit it with it being blank. So just keep that in mind. And then, is it an identifier? This is not an identifier, but if it was, we could say yes. And towards the end, when we're downloading the combined data set, we can strip out all of the identifiers. So just one of those things to think about. And that's sort of what it's going to look like when you're going into when you create this and it's a project, you'll have the option to pick what their vision was. You could have an option for not applicable. You could have a vision for, no vision. This is going to depend on what you need. But just for a quick look at sort of how that works, you'll see that it creates the data dictionary for you. And you can even download the data dictionary right here based on what you have put up. So I won't spend too much time on this right now. We can definitely create maybe an example project in the future if you'd like. But the functionality is almost exactly the same as if you were using Excel. Only the benefits are that you get to create something that other people can contribute to, and it puts everything into one giant form. And it does a lot of the hard, the data dictionary parts for you. It does a lot of the naming, a lot of the stats ready components for you, which can be nice. I think I don't want to take too much of your time here, and I'm going to have to move on as well. So are there any other questions that we have before I go?
No questions from here. Any others in the Zoom call? Anybody want to ask some questions to Mr. James? I presume there are no more questions. So
All right.
thank you very much, Mr. James, for spending some extra time and helping us be oriented towards RedCap also. And you gave a lot of tips regarding how to manage Excel better. So we'll have those points in mind when we create our next Excel sheet. Thank you very much from Aravind Eye Hospital.
Thank you so much for having me. It's been a pleasure. This has been awesome. So thank you very much. Feel free to reach out to me too if anything comes up after. You have my email. I'm happy to answer anything offline. Give tips later. Okay.
Thank you, Mr. James. We'll close the Zoom call. We are already late.
Perfect.